In this video, I'm going to give you guys some help with section 5.1 and 5.2 using Microsoft Excel for discrete probability distributions and then the binomial distribution. So here I have a good example that covers the expected value here, which we also call the mean, and we use mu for that. We have the variance, sigma squared, and we're going to find the standard deviation sigma. Now when we have a probability distribution, we're going to have to do these the long way. But Excel is still going to help us a good bit. So I'm going to copy these data over to Excel. So our formula was that mu, or the mean, equals the sum of the x's times their probability. All right, so what we're going to do is we're going to take each x, or each value, multiply it by its probability, and then after we get all those products, we're going to add them up. All right, so I'm going to start a new row over here. So these are the data that I copied, and I'm going to do x times p of x in this row. Okay, so I'm going to hit the equal sign to enter a formula. My value for x is right here. For my multiplication, shift 8 for that asterisk, and then the probability is here. Now I need to do that for each value of x. What's nice is if I already have a formula here and I have that cell selected, if you see that little tiny box down there, that little handle, if I grab that and drag it, it will apply the same formula to these other cells. So for example, let me highlight this one. This one is C1 times C2, or 5 times 0.2. So what I've done so far is take each value, multiply it by its probability. Now what I need to do to get the mean is I need to add those up. I'm going to start over here. We're going to call this the mean equals, I'm going to use SUM, sum, to tell x to add some things up. And I'm going to select all the things I want to add up, which is B3 through F3, and I get a mean of 5.7. Next, I think we were asked to find the variance. So for the variance, sigma squared, well, the first thing we're going to do is we're going to add up each value squared times its probability. And then once we get that sum, we're going to subtract off the mean squared that we just found. Okay, so now I'm going to start a new row, and this is going to be each value of x, which I square, and then multiply it by its probability. And we hit equal sign, then the value for x in this case is 4. To square it, I'm going to use the caret 2, and then we are going to multiply that by its probability. Okay, and as we did before, instead of copying that over 4 more times, I'm going to grab this little handle here and drag that to apply that formula to my other columns. So now for my variance, the first thing I need is the sum of the values I just calculated. So I'm going to type sum, open the parentheses, select those values. And now I want to subtract from that the mean squared. So minus, well, the mean I have right here above, 5.7, which I'm going to square. Next, we're going to need the standard deviation, right? So sigma, or the standard deviation, is just the square root of the variance. I'm going to hit the equal sign. Now to get the square root is SQRT. Open the parentheses, and the thing I want to take the square root of is this variance that we just found. So next, we are asked to find the probability that x is less than 8. Now, this is important. Notice that there's no line under this. So this is strictly less than 8. So that's any number smaller than 8. We are not going to include 8. So that would be 4, 5, 6, and 7, but not including 8. So that would be these 4 right here. So if we add those together, 0.3 plus 0.2 plus 0.2 plus 0.1 would give us 0.8. In our next one, now we want strictly greater than 5, not including 5, but everything larger than 5. So I think that would be 6, 7, and 8. So if I added those up, 0.2 plus 0.1 plus 0.2, I think that would give me 0.5. So for the mean, variance, and standard deviation, you're going to have to do a little bit more computation in this section, but I don't think it's too tough. All right, another one I want to talk about is when we're comparing these two plans here. So what we want to compare is the mean of plan A and the mean of plan B. So here's what we're going to do. We're going to copy these to Excel and then find the mean just like we just did and see which one has the greater mean. So here's plan A, and I just hit the copy button from Hawks. We're going to think of these payouts as our X and then their probabilities in the second column. So again, let's write that formula one more time. Mu is the sum of the x's times their probability, P of x. Okay, so for this case, I'm going to need a new column, which is x times P of x. Put my equal sign, my value for x is over here in the payout, times its probability is right beside it. Now we can use that trick we did before where I grab this little handle and I drag it down. Now you'll notice that in these two cells it says value. Well, we can delete those, right? Because there's nothing pertinent there. Okay, now to find the mean of plan A, or the expected value of plan A, I'm going to hit my equal sign and I'm going to add these up. Sum, open the parentheses and select the things we're adding up. And then we can do the same for, it's going to be the sum of these. So in this case, it looks like plan A has an expected value or an average return of about 45,400, whereas plan B has an average return or a expected return of 80,650. The next one that I think you might need some help on is this one where we are not given the probability distribution, but we have to come up with the probability distribution. Now in my version, what made this a little tougher than the others is that I have 5 coins here, and we want to know every single combination of heads and tails. Well, if you remember from the multiplication rule, I think this was section 3.3, if I have 5 coins, I have 5 options for each, and we multiply those to find the total number of outcomes. Okay, so my first coin could either be head or tail. I have 2 options there, times second 2, 2, 2, 2. So there are going to be 32 things in my sample space. Now with 32 outcomes in my sample space, it's pretty easy to overlook one or double count one or miss one. So I want to help you with this, and then I'm going to show you a shortcut using the stuff that comes up in 5.2 for the binomial distribution. So let's start with no tails. Well, that one I think is pretty easy because there is only one way that we get no tails. That would be if every single coin was a head. So this is just one outcome in my sample space out of the total of 32. Then if we have one tail, that tail could either come first, second, third, fourth, or fifth. So there are going to be 5 out of 32. For 2, this is where things get a little tougher. If I had 2 tails, well, I'm going to chunk these. So let's start off right here. One of those tails is going to come first. And then the second tail could come second, third, fourth, and fifth. Now let's say, okay, one of those tails comes second. Well, the second tail could come third, fourth, or fifth. And then one tail comes third. The second one could come fourth or fifth. And then lastly, both tails come fourth and fifth. So here we have 10 different ways. So this one's tough out of 32. So for three tails, it's very similar to two tails, because if you'll notice for two tails, each time I had two tails and three heads. Well, now we just want to reverse that and have two heads and three tails. So if I change every single tail over here to a head, again, we end up with 10 out of 32. For four tails and one head, well, that one head could come first, second, third, fourth, or fifth. So again, we end up with 5 out of 32. And lastly, there's only one way I can get all 5 tails, which shows up 1 out of 32 times. Now, like I said, with 32 things in your sample space, it would be very easy for you to miss one of these. So what I want to do now is go ahead to section 5.2, the binomial distribution. So here, if you notice, we have a fixed number of trials. There are 5 trials. Each coin flip is a trial. All coins are independent. One coin doesn't affect the next. They are either a success or a failure, or in our case, a head or a tail. And the probability of a tail stays the same throughout each trial, which is 0.5. So this is binomial. So what I want to show you now is how to do this using the stuff we haven't quite gotten to in section 5.1. This is in 5.2. If this is binomial, we can use our binomial formula. So I'm going to hit the equal sign over here in Excel, binomial. So I think the code here is binom.dist, open the parentheses. The number of successes we have, well, that's going to be 0, 1, 2, 3, 4, 5. So I'm going to select 0, which is right above, comma. The number of trials is 5, comma. The probability of a tail is 0.5, 0.5, comma. And we do not want this to be cumulative, so I'm going to put a 0 in this last spot. So again, if we want to apply that same formula to these others, I'm going to grab this little square down here. You see my cursor turns to a plus sign. I grab that and drag this over, and we get those probabilities. Now these are decimals. They might not look like what we just found, but if we right click over here, format cell, want this as a fraction, you'll notice here we had 1 out of 32, 5 out of 32, but then here we get 5 out of 16. If you remember reducing fractions, 5 over 16 is the same as 10 over 32. So that might be a little easier to do if you have read ahead to section 5.2, but that's why I wanted to help you with this one, because the sample space is very, very large. With 5 flips, there are 32 things in your sample space. Moving on to section 5.2. There are 2 ways to do these problems. You can either use Excel, which I'm going to show you, or you'll see over here there is a table feature, both in the practice and in the certify, which would also help you. So in this first one, we have n equals 10 folks, and we want to find the probability of exactly 8 when the probability of a success, p, is 0.5. So if this is binomial, first let me show you how to do this in Excel, and then we'll come back to using the table. So what I want to find is the probability of exactly 8 out of 10. Okay, I'm going to hit the equal sign. Then we want binom.dist, open the parentheses. The number of successes, we want 8 of those, comma. The number of trials was 10, and then the probability of a success was 0.5. Do we want this to be cumulative? No, so I'm going to put a 0 there. You can either do 0 for false, 1 for true, or type the words. So I'm going to put a 0 there. Okay, again, the order here is X in P, and then the last input you're going to give it is a true or false or a 0 or a 1, whether we want this to be cumulative. We do not want cumulative because this was exactly 8. It didn't say less than or equal to 8. So we got 0.044. Okay, now if you're using your tables here, you're going to click on the table, and then we have the very top, you want to select the binomial probabilities, not the binomial cumulative, because this is just exactly 8. Then our number of trials, we want to choose 10. And we're looking here at the column for 0.5, because that's the probability we were given up here. And our X value, which is over here, is 8. So I'm going to look in this row, and we get that same probability that we just found in Excel, 0.04, if we round that to 3 decimals, 4. It might be a little easier in your tables, or you're welcome to use Excel. Now this next one is also binomial, but the tricky part about this one, this is less than 4. So let's see, if we had 6 options, it could be 0, 1, 2, 3, 4, 5, or 6. Okay, what we are interested in is strictly less than 4. So do you guys understand that there's no line under this less than sign? So we're not going to include 4. We want everything less than 4. So what we want are these guys right here. Now the problem with our cumulative distribution is our cumulative distribution does less than or equal to. So what we want, the probability that we're strictly less than 4, well, do you see that that's going to be the same as the probability that we are less than or equal to 3. So we are going to see if we can do this one using both strategies. So if I want to find the probability that X is less than 4, well, we need a less than or equal to. So we're going to do the probability that X is less than or equal to 3. So that's when I'm going to use my cumulative distribution. So equal binomial dot dist, open the parentheses here. We had the number of successes here, not 4, we're going to give it 3 because this is less than or equal to. The number of trials was 6. The probability was 0.03. And this time I'm going to enter a 1 here because I do want this to be cumulative. I want to start at 0 and count up to 3. So I get 0.9295. Now let's see if we can get that same thing with our tables here. So if you click your little table button, now this time we're going to choose binomial cumulative because this is a cumulative probability. We want 0, 1, 2, and 3. We're going to choose N, which is 6. Now the column we're going to look at is P for 0.3. And again, even though we want strictly less than 4, but our cumulative distribution is always less than or equal to. So I'm going to look right here at less than or equal to 3. And again, we get that same value, 0.9295. In our next one, we have N is 19. We have P over here, the probability is 0.3, and here we have x equals 5. Now, this is at least 5. So if we have at least, I think, is a greater than. So let's say it could be 1, 2, 3, 4, 5. All right, and I'm going to go dot, 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 17, 18, or 19. Okay, at least 5. So it could be 5, it could be 6, it could be 7, 8, 9, 10, all the way up to 19. So all of this stuff that I just circled right here is at least 5. X is greater than or equal to 5. Now here's the hard part. We just said that our cumulative distribution always starts at 0 and counts up. So what my cumulative distribution is going to find is this piece. It can tell me the probability that x is less than or equal to 4. Well, if you remember, probabilities always add up to 1. So to find the stuff in blue, I can do 1 minus the stuff in green. So the probability that x is greater than or equal to 5 is going to be 1 minus the probability that x is less than or equal to 4. We're going to choose cumulative again. We go down to when n is 19. The column we're looking in is the 0.3. What we want to look up is less than or equal to 4, which is this value. Now I'm not done yet, because if this is the stuff that I have over here for less than or equal to 4, well, to get the stuff greater than or equal to 5, I need to subtract that from 1. So we're going to have 1 minus 0.2822, which would give us 0.7178. All right, so what we are interested in is the probability that x is greater than or equal to 5. Well, to find that, I'm going to do 1 minus the probability that x is less than or equal to 4. So I'm going to put my equal sign here, then do 1 minus binom dot dist. The number of successes here is 4. The number of trials was 19. The probability of a success was 0.3, and we do want cumulative. And we get the same value there. Here we have another cumulative, but this is strictly greater than, so it might help you to write this out. So if we have n equals 5, I could have 0, 1, 2, 3, 4, or 5. Strictly greater than 1 is not going to include 1. It's going to be 2, 3, 4, and 5. So this stuff is the probability that x is strictly greater than 1. Well, again, our binomial cumulative distribution always starts at 0. So what we're going to do is we're going to find this stuff right here, the probability that x is less than or equal to 1, and subtract it from 1. So the probability that x is greater than 1 is 1 minus the probability that x is less than or equal to 1. So if we go to our table, we want the cumulative distribution, because this isn't just one value. N here is 5. We're going to look at the column for 0.8, and we're going to find the value for less than or equal to 1, which is 0.0067, and subtract it from 1, which will give us 0.9933. Let's see if we can get that same result in Excel. The probability that we are strictly greater than 1 is the same as 1 minus the probability that we are less than or equal to 1. So we're going to hit equals 1 minus our binomial distribution. The number of successes is 1. The number of trials is 5. The probability of a single success is 0.8. And we are going to enter a 1 in this last one because this is true. We do want the cumulative distribution. And again, we get 0.9933.